Okay, for topic 5, we're going to discuss circles, okay? We introduced the idea of a circle in a previous section. Obviously, we all know what the shape of a circle is. What you really need to take from the previous discussion is what is the diameter and what is the radius of a circle. So remember, if we have a circle, okay, from the center to any point on the edge, we have the radius. And then if we have a circle, let me try that one again. That one got kind of messy. And then if we have a circle through the center all the way across the circle is the diameter. And what we really need to know is that the radius is half the diameter and the diameter is twice the radius. We need to remember that, okay? Now, when it comes to perimeter, we don't call the distance around a circle the perimeter. We just don't. Perimeter is kind of specific to polygons. For a circle, the distance around a circle is called its circumference, okay? And we have two different formulas. One involves the radius, one involves the diameter. They're essentially the same thing. So the way I determine which one I'm going to use is which value was I given in my circle, the radius, or was I given the diameter? Now, these formulas do involve pi, okay? So pi, just plain old pi, it's a Greek letter, looks kind of like this, okay? This is a Greek letter that is, it's an irrational number, meaning it never terminates, it never ends. It's a decimal that just keeps on going and going and going and going and going. And that's not terribly realistic for us to use. So instead, we'll use approximations for pi. So two really common approximations for pi are 3.14 or 22 over 7. So generally speaking, we stick with 3.14, but you could absolutely be asked to find some aspect of a circle using pi as 22 over 7, okay? Now, depending on which one you're told to use, you really do need to use that one, okay? So we're going to go over to the calculator for just a second so you can kind of see why. So let's go to the calculator. Okay, so 3.14 is just 3.14. Okay, so if I took 3.14 and I multiplied it by 565, I would get 1,774.1. That's great. Okay, well, what if instead I used 22 over 7? Okay, so instead of 3.14 is my approximation, I did 22 over 7. I'm just going to write that as 22 divided by 7, and then I'm going to multiply it by 565. Well, this time I get 1,775.714, blah, blah, blah. Well, why is that? Well, if I take 22 and I divide it by 7, I don't get exactly 3.14. I get 3.142857143. So when I multiply it by a big number like 565, with those extra decimal places, it's going to make my answer bigger than my truncated 3.14. Okay. Similarly, if we were to look at the pi button on a calculator, for this particular calculator, it says that pi is 3.1415, 3.14159,264. So if I take 565 and I multiply it by pi, I'm going to get 1,774.999849. Okay, so we got three completely different answers depending on which approximation for pi we used. Okay, so you really do need to use the approximation for pi that you are asked to use, especially if you're doing some kind of an online homework, because our online homeworks are going to be programmed to accept certain answers. And so if they say use 3.14 for pi, but you use the calculator button, you're going to get potentially a different answer that's different enough that your online homework can't recognize that it's really correct. It's just used a different format of pi. So be very cautious with this. Make sure you use the correct approximation for pi, whether it is 3.14, 22 over 7, or even the button on your calculator is another approximation. Okay, so just be very diligent with that. All right, so back to our worksheet. I will say for me, if I don't specify what I want you to use, 3.14 is probably what you should use for me. Okay, depending on who your instructor is or your online homework, that may vary. Okay. Now, for example 5, it says find the circumference of each circle below. Well, we have these two formulas. They're listed above. The two formulas are circumference equals 2 times pi times the radius. And then we also have that the circumference equals the diameter times pi. These are actually the exact same formulas because 2 times the radius is the diameter. So essentially, we're just taking the diameter and multiplying it by pi. Okay, so for part A, I do say find the circumference of each circle below. Use 3.14 as your approximation for pi. And in the circle that I have for part A, I'm given the diameter. This is my diameter. So I'm going to use the formula that just contains the diameter. Why not? Okay, so capital C for circumference equals the diameter, which is 40, times pi. Now, there will be times where you're asked for an exact answer. If a direction say find the exact value of the circumference of some circle, this is it. Just leave the pi in your answer. So I would say 40 pi centimeters, and this is exact. But we were not asked to give exact values. We were asked to give approximations because they told us to use 3.14 for pi. So that is the exact answer, 40 pi. But we want something that's a little more easy for us to understand. So we're going to get a decimal approximation. So we're going to take 40 and multiply it by 3.14. Just use your calculator. So you can do 3.14 times 40, and I get 125.6. So the circumference is 125.6 centimeters. And I would probably go ahead and use an approximate equals, the little wavy equal sign. That means that we've rounded at some point. So we could say our circumference is approximately 125.6 centimeters. Okay? Now for part B, same thing. The difference here is we were given the radius instead of the diameter. So I'm going to use the formula that involves the radius. So the circumference equals 2 times pi times the radius, which is 21. So if I clean it up a little bit and take 2 times 21, I would get 42 times pi. And again, we're using centimeters. So this would be my exact answer. If directions ever said, hey, what's the exact circumference of this circle? I would have to say 42 pi because pi goes on forever and ever. There's no way for us to get an exact value unless we use the symbol for pi. But we want to approximate it because the directions very clearly said use 3.14 for pi. So we're going to say, okay, this is 42 times 3.14. And just type that into a calculator. So 42 times 3.14, I get 131.88 centimeters. Okay, so that is finding the circumference of a circle. Nothing terrible, just be really mindful of what approximation for pi you should use. Or if the directions ask for an exact, just simplify and then leave pi in the answer. Okay? And then one more example down here. Well, let me scroll. There we go. So it says solve the following problem, include units with the answer. It says a rectangular lot measures 65 feet by 150 feet. Find the cost to install fencing around the lot if the fencing is $2.25 per foot. I probably should have done like an additional topic and called it applications, but all of these videos were kind of short, so I just decided to throw this one in at the end. It has nothing to do with circles. It's completely rectangular, but anyway, I don't know, just felt like this was the right place to add it. Okay. So we do have a rectangular lot that measures 65 feet by 150 feet. So I've got 150 feet and then 65 feet. Okay. We want to put in fencing. So kind of think about this. Fencing goes around the outer edge of some area. Okay. Not, I don't want to say area, some yard or some space. We'll say that's a better way to do it. So if we want to find the perimeter here, we could easily just do P equals 2 times the length plus 2 times the width. Remember, that's the formula for the area of a, or not the area, good Lord, I gotta stop saying that. This is the formula for the perimeter of a rectangle. Okay, so if we want to find the perimeter, which we would in order to find the value for the fencing, we're gonna have to find the perimeter first. Okay, so we're gonna take 2 times the length, which is 150, plus 2 times the width, which is 65. And because we have the order of operations, we do need to make sure we do our multiplication first and our addition second. So 150 times 2, you might recognize that as 300. If not, you could certainly use your calculator. And then 2 times 65 is going to be 130. And then to add those, 300 plus 130, that's pretty easy. We just get 430 feet. So the distance around this rectangular lot is 430 feet total. Okay. Now that doesn't really answer the question that's being asked. The question wants to find the cost to install fencing around the lot if the fencing is $2.25 per foot. So for each foot, all 430 of them, we're going to get charged $2.25. So we need to take 430 times 2.25. You could certainly use your calculator. As long as you show your setup, you're free to use your calculator. So we're going to get 967.5. Now keep in mind this answer is money, so we want to make it look like money. So we're going to put a dollar symbol. And then dollar values always have two decimal places. So we're going to write this as $967.50, okay? And we would say, is the cost to fence in the lot? Okay, and that's your final answer. So again, has nothing to do with circles. I just didn't feel like doing a completely separate topic, okay, in a really short video. So there you have it. That is how you would calculate the cost of fencing for a rectangular lot measuring 65 feet by 150. All right.